Welcome to the Control Engineering webcast, truly open and secure machine control, 7 steps to a modern, flexible, and secure machine design, sponsored by Emerson. I'm your moderator, Mark T. Hosky, and I'm happy to join you today on behalf of Control Engineering. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for the speaker in the Ask a Question box on the left side of the screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of the screen. Those documents also will be available with the on-demand version of the webcast. Now we'll hear from the sponsor of today's webcast, Emerson. At the conclusion of the video, you may experience a few seconds of silence to compensate for various internet speeds. Please stay tuned after the video for today's presentation.
When you look at the critical issues facing our world, what do you see? We see 1 billion more people breathing free. We see access to fresh food being the global norm, not the exception. We see homes staying cooler without the planet getting warmer. At Emerson, when issues become inspiration, focusing core strengths to create a better world isn't just a result, it's a responsibility. Emerson, consider it solved.
I'm happy to introduce today's presenter, Daryl Halterman. Daryl is a director of PAC System Controllers at Emerson's Machine Automation Solutions business, and he's responsible for the portfolio of Control Solutions modernization strategy. He enjoys working with customers to find the right modernization strategy to enhance their existing control solutions with the latest advancements in automation. Thanks for joining us today, Daryl. Now I'll hand it over to you.
Thanks, Mark, and good day, everyone. You know, it's been an unusual couple of years in the automation space, and as well as in just life in general. You know, a lot of unexpected events have occurred, and really, you know, we find folks struggling to try to make sense of the situation, to make good decisions out of the situation, and to cope with you know, rapidly changing environment in which they're you know, trying to do more with less. And you know, one of the observations that we've made is that, you know, in many recent years, there's been a trend towards, you know, potentially limiting upgrades or modernizations of existing control equipment because, you know, if it's working or it's running, well, that's good enough for the times. But, you know, as the times change, we find that sometimes the tried and true solutions aren't going to get us through the next big challenges that we're seeing. You know, it's like you might find yourself lost if you went out and tried to navigate today's world, you know, with your Nokia flip phone, or, you know, trying to meet the needs of getting around these days, you know, getting your kids from point A to point B in a 20-year-old vehicle, you know, maybe getting 10 miles per gallon and having some of the issues that you have with an older vehicle versus, you know, some of the modern conveniences and capabilities that are out there. We really are aware of the fact that, you know, machine builders and OEMs that are, you know, trying to cope with the very challenging environments that we're seeing today, you know, really could benefit from having, you know, the best-in-class and modern control strategies in place, modern equipment in place to be able to take advantage of some of the new technologies that are out there to help them to solve the problems of today and prepare for tomorrow. You know, and some of these statistics will certainly hit home, but just want to, you know, kind of help to paint the landscape out there for folks of some of the things that we're seeing today. You know, 68% of supply chain folks out there are saying they're seeing increases and disruptions, less notice of those disruptions, you know, trying to continue to supply capabilities and products out into the marketplace with a lot of uncertainty and whether they'll have the means and the needs that they have to fill those requirements. You know, we've been taught over the last 10 or 15 years that just-in-time manufacturing is the right way to go. You know, lean manufacturing, limited stocks, and only having what you needed just in time to be able to build and ship. And of course, you know, the last couple of years between COVID and supply chain disruptions and other impacts on supply chains have just really turned that on its head. At the same time, you know, recent statistics here in the U.S. are showing that we have more than 11.5 million open jobs. So, you know, way more open positions than there are folks that are unemployed and seeking job opportunities out there. And, you know, another side note on that statistic, you know, some recent literature has shown that about 10,000 baby boomers are retiring every day on average. So, you know, not only do we have economies and companies that are trying to grow to manage the uncertainty in the current environment, but they find themselves struggling to fill those positions that were that are being vacated by folks that have the most experience, the most expertise, the most knowledge about how their plants and equipment were running in the past. And, you know, as they're trying to fill those new positions, they're finding themselves working with a new generation of employees out there, and they have different experiences and certainly different expectations of how they're going to interact with technology and equipment and what that means to them. Compounding these two certainly daunting challenges is the fact that you know, organized crime and other entities have discovered that they can actually make quite a bit of money by holding end users and OEMs data and plant assets hostage. You know, it used to be that we thought about it as being something that happened to nation states that were maybe had clandestine, you know, weapons programs, and then it moved into closer to home with, you know, oil and gas production and other infrastructure. Of course, in the last year, we saw people in things as mundane as, you know, meatpacking or other end user and consumer goods manufacturing being attacked with cyber attacks and finding themselves being held ransom for their manufacturing data. So, you know, it's a really tough environment out there, a lot of different variables coming together to really create a challenging environment. And you know, those outside pressures we now see putting additional pressures onto leaders and people that are responsible for production in their plants or in their delivery site systems today. You know, trying to continue to meet high productivity demands, being able to deliver on time to customers' expectations with really constrained resources, not always having access to the standard equipment that you were expecting and being able to make do. You know, as I mentioned, that transition, not only at the gap in labor in general, but, you know, a transition in the experience and the expertise of new labor coming into the market. You know, we often refer to those newer generation as being more interested in configuring applications rather than developing applications. So, you know, it comes from their experience with the internet and with apps and phones, and just that higher level of expectation towards instantaneous access to data and information. And in order to keep up with that, you know, technology is changing to meet the needs both of the environment and of the workers that are going to use that. And it really does mean that you need to take that into consideration, how to evolve to keep pace with technology changing so that you can take advantage of those things. And finally, you know, within that cybersecurity environment, oftentimes end users are looking towards their OEMs to provide guidance about setting up systems, being able to monitor systems, being able to recover systems in the event that they have one of those very unfortunate incidents that occur. and that's driving more of an expectation towards partnership between customers and end users. So in light of those things, we kind of want to lay out a couple of topics to really think about as you're looking towards modernizing control solution and control strategies to be able to take advantage of all the opportunities that are out there and best prepare you for this uncharted territory that we seem to be in these days. Certainly we look at some aspects of technology and how they can allow you to accommodate supply chain disruptions and constraints that we're seeing today. Being able to use technology to match the skill sets of new workers to the work that we need to be done. Reducing risk and providing a robust strategy around cybersecurity and protection of assets and information. Being able to increase productivity and in the face of constrained supply chains and other pressures, being able to move forward confidently into these new technology realms and making sure that you don't have buyer's remorse in 3 years, but also that you're not missing out on some of the trends and technologies that your competitors are looking to be able to employ with speed and precision as well. Finally, being able to enhance that OEM and user experience and partnership to be able to provide mutual benefit both for OEMs and end users as they're moving forward towards these uncertain times. And then, finally, being able to make some considerations as you assess new technologies and how that winds up affecting your overall budget in terms of, machine control costs as well as labor and resources to be able to implement those things. So, when we talk about supply chain constraints, really the big message and the big takeaway here is, solutions that can provide open communications and open connectivity will provide you the most flexibility in terms of being able to meet requirements in an application space. Certainly we've seen situations where, a machine may require a particular type of sensor that may be unavailable from a vendor A with little notice. If you have picked a proprietary communications interface for those sensors, you may be stuck. However, if you've chosen open communications interfaces for those sensors or devices, you may have options available from a vendor B, or having a control solution and strategy that supports multiple open standards means that when vendor A or B might not have that sensor, on your preferred communications interface, they offer it in a secondary open standard, and you can easily transition to that as well. So, having that flexible open communications capability in your control solution will allow you to have more options and be able to make transitions more quickly and more seamlessly to your customers. So in our cases, open standards that we see having a lot of viability and value in the current environment, OPC UA with security, Profinet for I/O devices and instrumentation, Modbus. Certainly it's been around a long time and maybe not necessarily the most secure protocol, but it's probably one of the most prevalently available in the market today. And that certainly has value, again, in flexibility. IO-Link is a new player on the market, come along in the last few years, but last research report that I had seen on that said more than 20 million devices had been deployed using IO-Link in the past few years. And so that means that it provides a great level of flexibility as well as simplicity as well. And for those who may be deploying equipment into infrastructure or other more industrial applications, BMP3 certainly is a very popular protocol, especially in the Americas or in environments that are using power grids that were designed by American consulting firms or contractors. So, just some examples of some of the open standards that we think would really help customers to benefit. So other things to think about, certainly the languages, the communications protocols that you have available at your fingertips are important. Then making sure that you've got the right technology infrastructure in place to take advantage. In this day and age, gigabit communications are really becoming quite a standard within the industry. And that, of course, allows you, a tenfold increase in the amount of communications data on a particular network interface. So that's one of those things we think it's important to look forward to help future-proof your architectures. And then, of course, looking for control equipment and technologies that may have integrated Ethernet switch capability or intelligent switching in the portfolio. Certainly, that allows you to take advantage of more flexible network interfaces and infrastructure without a lot of added cost or complexity. So, having open standards and flexibility in the protocols that you support, as well as the hardware technology, can really help you take advantage of things that come up to be able to fill gaps in short notice. So we kind of move on to that second topic, being able to expand the labor pool given resource shortages and constraints. Certainly, within the industry, the tried and true IEC 61131 programming languages, ladder, structured text, function block diagram, and the like, still remain very popular, very prevalent. Some of them are starting to show signs of age in terms of the ability to efficiently tackle problems, based on their expectations of architectures. But they still do a job, and it's quite common to find folks that are familiar with those languages to be able to program and troubleshoot. For next generation programmers, though, certainly, having the flexibility to support more modern, more structured languages within your space will broaden the type and the number of people that could contribute to the development and the management of your control applications. And of course, C and C++ being, stalwart programming languages that have been available for many years, high levels of efficiency, able to attack and address complex applications and algorithms quite easily because of the nature of those languages. And a newcomer, for the past 3 years in a row, Python has been the most popular programming language on the planet. More than 30% of respondents said that was their preferred and primary programming language that they're using. And folks might ask, well, why has Python become so popular in the last few years? And it really does come down to the fact that it is the most commonly used language for machine learning and artificial intelligence open source activities. And given the prevalence and interest in machine learning and artificial intelligence these days, lots of people are jumping on that as a programming language to learn and be able to deploy. So being able to look for control solutions that not only offer the traditional IEC programming languages, but some of these more mainstream IT programming languages will provide you with a greater level of flexibility in who can program your products, but also may be able to extend the capabilities of your control systems to solve new problems based on the abilities that are gained with these new languages. So regardless of the languages that you are using and deploying, one way to really get more capability out of the programmers that are working on your control solutions is to provide them with an environment that takes advantage of code abstraction, code reuse, and being able to provide good design standards and interfaces. So look for tool sets that will allow you to program with variables rather than register sets or references. Being able to refer to the flow rate of pump station 1 as flow rate of pump station 1 in your application code certainly simplifies it. It makes the development and maintenance of that application code more streamlined, more efficient, easier to understand. Look for products and technologies out there that allow you to build libraries of functions, both predefined libraries as well as potentially supplemental libraries, and then tools that allow you to extend those existing libraries with libraries of your own. So having things like support for user-defined data types, user-defined function blocks, being able to create your own standard program descriptions, your own standard programming blocks will certainly improve productivity of engineers and developers, certainly by being able to standardize code bases. It reduces risk of introducing bugs when you're interfacing between different systems if you've got standardized code and source code, and certainly allows things to progress much more rapidly. So, certainly best-in-class recommendations, regardless of the protocols and languages that are being used for your development. So, kind of tackle that third topic now, which is cybersecurity. And For many years, folks within the industrial automation space said, my control systems are air gapped. I don't really have to worry about security because folks can't get to my control equipment. And, then 2020 and the COVID shutdown happened, and folks found that they needed to continue to operate water treatment facilities or manage the maintenance of their factory automation spaces from their homes, or from other remote locations. And that meant that many folks were experimenting with remote connectivity tools and with other remote monitoring and diagnostics packages, being able to, in some cases, turning those on for the first time. Learning the hard way that, not having a good security strategy around those new tools can really lead to some very dangerous side effects within those systems. But really, as we think about those control equipment today, you really do have to, come at it from the mindset that, you can expect that bad actors will be attempting to hack into your equipment and your systems. You need to have the layers and the tools in place to be able to provide a level of security that's appropriate for your application. Certainly somebody that's doing a standalone ventilation system, vending machine is going to have a very different security risk profile than somebody that's operating, a water treatment facility for a major metropolitan area, a power plant, chemical plant, or the like. And because of that, you need to look to vendors and to tool sets that provide you with a rich set of security tools and functions and guidance on how to apply those in a way that will provide robust security for your particular application. That really does start with the components that go into the equipment that you're going to field. So making sure that those vendors do have policies and procedures in place to make sure that the components and the software that go into the products that you're buying are genuine, they are secure. As they add application code for the runtime environment, making sure that those things are genuine. So, when you go to update equipment to add new features or fix bugs, making sure that it hasn't been tampered with, there's no malware installed in that. Being able to provide secure communications within the application space so that as you're transmitting data, you can do so with confidence and integrity. And then being able to provide tools and services to help you to assess the risk profile of your particular plant or application and what tools would be appropriate to apply in order to provide you with the level of security that is necessary for your particular application. So, it's more than just a box. It's more than just a protocol. It really is a comprehensive security suite and a set of capabilities as well as guidelines on how to best apply those that really do make the difference. No single vulnerabilities, the ability to detect and manage security intrusions as they may occur, and be able to recover from those intelligently in the event of the worst case happening. So we kind of move on, kind of talked about the downsides in dealing with, some of the challenges in this environment. There are also some opportunities that are coming along as well. Again, as IT and OT infrastructure are combining, there are new capabilities that are coming to bear. And, with that, it's probably a once-in-a-generation kind of opportunity to start looking at changing our overall control philosophies and our control strategies to take advantage of some of the new technology that's becoming available. Certainly looking for control solutions that are scalable, from small single equipment up to, say, plant management, being able to use common tool chains and common development capabilities across that will ease the adoption of new technologies and speed their deployment. Having the ability within a control solution these days to be able to take advantage of machine learning or artificial intelligence algorithms to do things like look for energy efficiency opportunities, look for overall equipment efficiency, be able to detect leaks or other waste of energy in a variety of forms, can be really important. But you have to have the right infrastructure in place to take advantage of those things. Additionally, more connectivity can provide opportunities to put the right information into the right hands to make faster decisions. But you need to have the right infrastructure in place to really take advantage of that. That starts out by having that high-speed communications capabilities built into the solutions that you're looking for, but also, having equipment and technologies that are providing the data in context. So, you may be looking at the health of a pump station in a particular application. It may have a flow rate, it may have a pressure, it may have a temperature, depending on the material that's being transferred. There may be some discrete data points in there that tell you whether it's on or off, or what rate it's pumping at, if it's got faults present, those kind of things. Looking for solutions that are able to provide that set of information about that piece of equipment in context. So, having the engineering units already pre-configured for the pressures, temperatures, and the like, before it comes to an operator that needs to interpret that information, or a decision maker. Bringing back the fault information in context with the actual output of the system so that folks can make a better assessment on whether, the risk that's involved in the alarm that came back, and maybe even be able then to diagnose it based on the behavior of that system, really does mean that you need more than just data points. You need to have contextualized information. So looking for control solutions that provide that context, as well as the data at your fingertips, is really critical. As we look to prepare for next generation capabilities, being able to future-proof a system, lots of folks are worried about that fear of missing out. They see lots of shiny buzzwords and new things coming along. They're not really sure how they necessarily would be applied to their spaces, but there is concern that, well, if competitors are able to better harness new technologies, that may leave us out in the cold. And the best advice that I can have here is, again, going after open solutions, going after open architectures will better prepare you to take advantage of those new solutions as they become available, and certainly can allow you to be more flexible as things adapt and evolve. And so, one of the strong recommendations that we make is look for systems that do support OPC UA and OPC UA Secure as a standards communications interface. It does provide data models and other data profiles that help you to really turn that information, the data that you're receiving, into information in context. And it is the preferred protocol of initiatives like Industry 4.0 and Factory of Tomorrow and those kind of things. So being on the broad open standard allows you to take advantage of those new things as they evolve. Additionally, look for automation solutions and automation portfolios that have a breadth of capabilities around Edge. Lots of folks have heard about Edge and IoT, and they're really interesting words, but they're not really sure what those words can do for them. Edge capabilities and providing a breadth of options there can really help you to solve a number of problems. It could be things as simple as just being able to consolidate data from different types of equipment or different vintages into a standard view of a system through something like an Edge gateway. Maybe I need to get a few sensor points back to a common repository to be able to view those. Edge compute may allow you to provide advising to an existing control system or a new control system by using real-time data from outside or non-traditional sources, along with algorithms to be able to come up with recommended optimizations for those control systems. Or you may be able to then combine those into a single unit in something that we call an Edge controller, which has a full deterministic control capability, as well as a separate and secure Edge platform to be able to perform real-time data access from non-traditional sources, from the web, from sensors, from other pieces of equipment, apply algorithms to that information, and then advise the control system in near real time how to change its behavior in order to take advantage of a changing environment to provide the best outcome for a particular customer application. The other recommendation that we would make is, looking for open standards and capabilities that allow you to build bridges between traditionally separated islands of automation. Many folks within industries may be familiar with distributed control systems at DCS, and we'll think about those as being, best in class for certain continuous process type applications, be it, refining or chemical processing, brewing, those kind of things. But even in environments where you have those fully running and continuous processes, you may have needs for high-speed control or management for things like power systems or compressed air, generating electricity, managing the ventilation or whatever it may be around those systems, or for small skids that do specific functions within that overall process, centrifuges, compressors, pumps, mixers, and the like, that may come in from an OEM, they may be built on site, but you would like to be able to integrate both the health and operational information about those devices, as well as being able to incorporate them into the overall control strategy. And there is an open standard that was released a few years ago from the NAMR group, and it is called Module Type Package, M2P. That's been one of those examples of an open standard that will allow you to have a seamless integration between traditionally PLC type applications and equipment and larger DCS systems. And it does so by providing an open standard API that, if you develop your PLC applications to that standard and your PLC equipment is properly enabled, you can actually produce from that control application an integration file that can be incorporated by a DCS. And, that file allows it to automatically set up communications exchanges, control interfaces, fault information, and the like. And that standardization can cut your integration time in half for traditional PLCs and DCS systems. So, again, being able to take advantage of that evolving technology means being able to integrate it rapidly into your development environments. So, moving forward to talk more about those OEM and end user partnerships. Again, as we mentioned, a lot of baby boomers retiring every day, a lot of skilled experience and expertise, leading a whole variety of industries. New folks coming in with different experience and different expectations, but the same productivity requirements, the same production schedules that we're trying to meet. In those cases, end users are looking today for more assistance, both from controls vendors as well as their OEMs, to provide guidance, to provide better troubleshooting, to provide better performance for the equipment that they're installing into their plants and their applications. And certainly, we make recommendations, if you're an OEM, take advantage of some of these capabilities, but if you're an end user, look to your OEMs to provide these kind of capabilities into their systems so that they can, provide as efficient maintenance capabilities as possible, be able to set up and manage fleets, to be able to really meet your needs as they may be changing. So some of the capabilities to provide efficient fleet management would be tools that allow you to be able to deploy and commission standard applications without a lengthy setup and commissioning process and procedure. Being able to deploy standard applications, being able to deploy upgrades to that standard machine control application in the field without a lengthy setup and management process. Say having a pre-canned updated program that you can put on a USB stick and just drop down onto the machine, provided you have the right authentication and authorization to do so. Really speeds things up rather than needing to connect traditional control application equipment, a laptop and the like, and set up. Additionally, being able to provide individual equipment tuning parameters and being able to save those to removable media is a really important feature. You may have 50 of the same machine in a particular plant, and you'll dial in the first machine and you want the other 50 to look just like it. If you can pull the tuning parameters off of that machine onto a removable media that you can then take down the line, maybe you set all 50 units up the same way very quickly and very efficiently. Conversely, you may have 50 units of a piece of equipment from an OEM that are deployed in 50 different places, maybe remotely. So, as they're installed, they're configured and tuned for that particular application space. And in those cases, maybe you want to make sure that, you don't lose those tuning parameters. In the event that you have a failure of the controller of the equipment, you can very quickly get your standard program deployed into that system, and then apply the tuning parameters for that particular place, again, without needing to go find a program, without needing to find a laptop cables and the like, just plug it in and go. Being able to provide remote firmware updates, remote updates of those systems securely is becoming an important feature that certainly allows OEM maintenance teams to stretch their resources further, but do it in a way that meets the integrity and the security of their end customers. And again, incorporating open standards for integration such as MTP can really help to speed the productivity and the efficiency of a customer. Conversely, building partnerships is about building trust, but sometimes you need to trust but verify. And so, looking to controls vendors that provide the tools and infrastructure such that, each party, the OEM and the end user, has the ability to identify and protect their critical intellectual property in an application and be able to manage that while providing access to the other party is really paramount. And so, looking for tools that have the ability to lock and encrypt OEM control algorithms so that they can have confidence that their proprietary control capabilities remain safe even when deployed in a variety of spaces, but also looking for tools then that can identify critical customer information. So certainly they may not want to share recipes, they may not want to share production quality information with an OEM because that OEM supplies equipment to some of their competitors. So being able to identify their recipe production type information as being able to view that remotely, securely, without necessarily providing access to that to the OEM is really the ability for each person to keep what they see as most important confidential. And then, of course, look for equipment that has standard secure and encrypted communications capabilities built in, which means that whether you're deploying, your control application or the critical production data, that you don't have the opportunity for, interlopers to break into a network and snoop that data, while it's in transit to or from the machine. So, providing an environment where folks can trust but verify, have confidence in the integrity of their information, but still be able to share and make best use of best resources where they're available. So, we've talked about a lot of different concepts and capabilities over the last few minutes, and certainly, folks will look at that and say, well, there's new opportunities, but of course, change is never easy, change is never free. If I'm looking to make a transition to a new solution, what kind of things do I need to consider in the overall cost of the system, and how might that affect me? So, one of the things that we recommend is when you're looking for control solutions today, you want to make sure that you're cognizant of the overall cost of the system, not just necessarily the individual components that you're purchasing to put together for your solution, but how you have to interact with those components in order to get them up to a running state so that you can actually deploy a machine in the field or make maintenance and service of that. We've seen trends from some automation providers out there recently to basically provide blank boxes or blank pieces of equipment. You may get a controller that comes with a firmware bootloader, and that's it. And so, the first thing that you need to do is have an operator go in, apply power to the system, connect to a website, download application firmware onto that system. Then you may have to download and license additional protocols or other algorithms that you may want to use on that. Some folks that are offering solutions that are more industrial PC with soft PLC and other interfaces on it, again, they come as a completely blank box. So in that case, you may need to have to download and install an operating system, set up security and parameters for that. Then you have to download and license the soft PLC runtime that they're using, get the credentials and stuff set up for that. Then you can apply your application code and any of your other analytics or applications. And again, within those systems, you may need to on your own, make sure that you got the right performance and priority settings within that operating system to make sure that, that soft PLC interface doesn't interfere with your analytics or vice versa. Your remote connectivity and analytics don't interfere with the deterministic performance of that soft PLC. So, looking for systems that come with all the tools that you need pre-installed, all the tools that you need pre-licensed, so for protocols, for functionality, so you don't need to necessarily download additional licensing in order to enable things like OPC UA Secure or motion functionality or the like. And the final thing that we talk about is looking for systems that are pre-integrated. So again, in many cases today we're seeing solutions that are coming out that would require quite a bit of configuration and integration of the different tool sets from an end user or an OEM to be able to get to a place where it's ready to deploy your application. Look for vendors out there today that are providing those solutions pre-integrated. So control capability, motion safety, visualization, potential for analytics with standard interfaces, standard software suites that are pre-installed, so that you can take advantage of those with a minimal amount of labor and time at your place, and minimizing the opportunities for mistakes that are made as those systems are set up to coordinate them into a single system. So. Again, looking beyond just the base cost of particular pieces and components, but really looking at, what is the all-in cost to be able to get from, components in a box up to an operating piece of machinery at a customer site. So, kind of a quick summary here to highlight the topics that we talked about. Some of the key challenges that we're seeing from the marketplace today. Supply chain constraints and disruptions that we're seeing. Again, a recommendation there is to look for solutions that have open communications packages, open communications protocols, potentially multiple open communications protocols that will provide you with the best flexibility, make it easiest for you to adapt your applications to equipment and components that may be available at the current time, and be flexible as those things may change over time these days. To manage skilled labor shortages that we're seeing out there today, look for products that provide open programming, potentially non-traditional, non-IEC programming environments, as well as those traditional programming environments and languages to provide you with the best flexibility so that you can take advantage of the skilled labor that is out there today, be more flexible about who you can hire, who can operate and manage that equipment out there, and look for solutions that have those tool sets to be able to provide add-on instructions, standard interfaces, and code reuse to really maximize the potential out of the resources that you have. From a cybersecurity perspective, of course, looking for a defense in depth strategy, multiple layers of security capabilities within the system, so that there's no single point of failure, there's no single soft point for hackers to go after to be able to manage those systems, tools and guidance on how to deploy those layers and capabilities as they are appropriate for your application and your industry, and guidance on best case and best use within that environment. Meeting productivity demands, again, looking for solutions and tools that provide the right access to real-time information, contextualized information, and not just streams of data, so that you can make those decisions more quickly and more confidently and in a more timely manner. Tools for coping with technology change, again, IoT-ready capabilities out of the box will help you to future-proof those designs. Things like OPC UA, things like Edge and analytics in the overall portfolio certainly will help you to be in a best position to take advantage of that evolving technology. Managing through OEM and end user partnerships, again, looking for control solutions that provide integrated fleet management tools and tools for providing security and integrity around data and information can help to build good relationships between OEMs and end users. And of course, then, budget and footprint. It's more than just the cost of the components. It's about the time, the labor, the maintenance of those those components, putting them together into a full solution that you really need to think about. As Emerson, we're cognizant of these challenges and opportunities. And, I would just mention that at Hanover Fair about 2 weeks ago, we did announce that we have a new compact control family, the CP200 series. We feel that it addresses many of the topics that we have talked about here this afternoon. And, it is really a platform that's ready to solve today's challenges and tomorrow's challenges. So if you have more questions about that beyond the webinar that we've conducted today, please feel free to check out our website. That's www.emerson.com/PAC-Systems-compact. That'll talk about the 200 series and some of the capabilities. You can certainly feel free to contact a local Emerson channel partner and ask for a product demonstration. We'd be happy to help you out with that. So that does conclude the presentation material for today. And with that, I think we'll transition over to the Q&A session. So with that, Mark, I will hand things back over to you.
Thanks, Daryl. Great information. Next, our presenter will answer questions from the audience. Please type your questions for Daryl in the Ask a Question box on the screen, and we'll get to as many questions as time allows. Questions that we do not get to today will be posted online with the archived version of the webcast, so even as we near the top of the hour, please continue submitting questions. Also remember to download a certificate of completion and a copy of the presentation by using the Event Resources tab on the left side of the screen. Now, on to your questions. So can smarter automation help fill the skills gap, and how?
Okay, that's an interesting question. Yeah, so, as I talked about earlier in the presentation, having better access to real-time information can help to make better decisions. And so that is one way that the more modern technology can help to bridge those gaps. Certainly by being able to provide critical information to decision makers wherever they might be, you'll find that, your key labor resources, be they in maintenance, be they in operations, can potentially manage more pieces of equipment in real time without necessarily needing to be next to them all the time. The other way that more advanced technology can help to fill some of those gaps is a little more cutting edge. And in those cases, I mentioned being able to take advantage of access of real-time information that may not necessarily be limited to traditional sensors and instruments on the PLC. So, we have some customers that are in applications, for example, doing floodwater control in a city here in the U.S. And in this case, they set up a control system with a machine learning algorithm that basically had a virtual machine of the or a virtual template of the water flow so that they could look at the reservoir depth depending on the amount of precipitation they got. And then they were able to hook that system up to NOAA weather forecasting information. And so, these are not things that you would expect to do with a traditional PLC, but by combining the data, real-time weather forecasting information from NOAA with that model of the reservoir, they were able then to manage the level of the water in the reservoir so that, they didn't spend any more energy and resources than they needed to pumping out water, but they also were able to manage flood control quickly and efficiently. The other important thing to point out there is, using an edge controller in that way, strategically, as Emerson thinks about those problems, we have purposely put together systems where we separate the traditional deterministic control from that edge interface. And we do that so that in the event that you had somebody that hacked and compromised that edge interface and algorithm, they don't actually gain access to your true control system. And so,
great. How are your offerings making multi-vendor environments easier for machine builders and for end users?
Well, as I mentioned earlier, really, Emerson is in our PAC Systems control portfolio are embracing open standards and open capabilities. So, Having OPC UA secure communications protocols as a standard capability within all of our PAC systems controllers, support for things like Profibus, Profinet, Modbus, other open standards protocols being native to the system mean that you can be quite flexible in terms of the devices, sensors, and instruments that you can connect to those pieces of equipment. Additionally, we mentioned that MTP standard module type package. That now gives us the flexibility to integrate to DCS vendors out there who support the MTP standard without necessarily having any direct interface to them. An OEM can develop their PLC application to the MTP standard, and the system integrator that's doing the DCS control system, their module type package integration file, and they're able then to coordinate those quickly and easily without the DCS vendor needing to know the details of how the algorithms are run within that PLC. So, again, providing a lot of flexibility and openness for those applications, for a variety of customers in a variety of industries.
Great. Do you think that machine designers have become more in tune with customers' needs in the last 5 years? How are available tools helping with that?
Sure, that's a great question. So I think there certainly are a lot of efforts going on to become more in tune with machine users' needs. And, some of that comes back to just getting better information about the fleets of assets that are being deployed. Having remote monitoring and diagnostic information about how the machine is operating, what modes it's being operated in, failure points on a fleet provide machine builders with a lot greater insight about how their products are being used, what's used, what's not used, what's working, what's not working well, and then being able to adapt those based on customer needs. Of course, there certainly needs to be some buy-in and participation from that end user. We talked about building those relationships. But again, once you build that trust, having the OEM have more insight into how you're using their equipment can ultimately help them to make equipment that's more effective for you. So, that's why it's so critical to have that trust by verify environment, so that you can take advantage of those capabilities.
Do I need any additional licensing or devices for using OPC UA?
In the PAC Systems environment, no. All of the PAC Systems controllers come with an OPC UA server standard. To turn it on, all you have to do is check one box in the configuration that says enable. They do come pre-licensed as well. We know that some of the competitors out there these days will require you to deploy a runtime license, be it through a key code or a software patch to be able to turn it on. But within the PAC Systems environment, as I said, we feel very strongly that that's going to be a critical capability to enabling IoT and other vendor interoperability in the future. And so we're offering it standard, pre-deployed, pre-licensed, ready to go.
Can these offerings work as hot swapping in redundant configurations?
So the 200 series is meant for standard machine control, and so they're set up as simplex controllers. Our larger RX3i products do offer hot standby redundancy capabilities with Profinet system redundancy. And the nice thing about that is, if you set up an application for the 200 series, they use the same toolchain, the same runtime, same programming languages, same communications languages between all of the PAC Systems controllers. So, if you decided that you'd set up a machine and you wanted to go to a redundant control solution, you simply can change to the RX3i family type. Just kind of a right-click, single button activity there. It'll switch over to that hardware platform, and then you can select a redundant controller there. So. Certainly, at the price point, the performance point of most mid-sized machines, we don't expect redundant control to be a requirement there. But again, we've got flexibility within the portfolio to meet those needs with a minimal amount of learning or retooling on the part of the OEM to take advantage of those.
For MPT, and maybe explain what that is, for Delta V, will this be in an FHX file type? Like a normal Delta V database files, or is there something more generic going to be available?
Yeah, so for module type package, as I mentioned, that's a standard API between the PLC programming environment and a DCS environment. Certainly, Delta V absolutely does support that. In that environment, I don't remember the exact extension of the file, but it's not the typical Delta V file, but it is an MTP standard file. I believe version 15 of Delta V does support that standard interface. And so effectively, you would export your MTP configuration file from our Machine Edition programming software, import that into your Delta V application space, and it will automatically then integrate that PLC with regards to the communications interfaces, the control interfaces, alarms, and such. So cuts about the work of integrating, a PLC subsystem about in half. So today you would still need to create the faceplates for visualization of that PLC system, but the Namer MTP standard does have provisions for automated faceplate development as well. And we do have that in our roadmap, and at that point it would reduce the development effort by about 90%. So with current solutions that we have today between PAC Systems PLCs and Delta V, for example, making use of the MTP interface will cut your integration effort in half. In the future, it could be cut by as much as 90%. So, we think that's going to be a great productivity capability. The other added benefit of that is, traditionally, if you wanted to integrate a PLC-based controlled equipment into a DCS environment like Delta V, you need to hand over the application logic or the algorithms to the DCS vendors so that they would understand how to create the interfaces for that machine. And obviously, that's for many folks that may be a bridge too far with handing over their intellectual property to a third party for that integration. When you go to the MTP standard, you can now have a nice, clean integration, communications, control, alarming into a DCS system without actually giving up your intellectual property. So we think it's a huge benefit to OEMs that would like to provide equipment into a DCS environment, to be able to, again, trust but verify, retain their intellectual property, but have the benefits of an integrated solution for that end customer. And we mentioned Delta V, as an Emerson employee, we know and love Delta V. It's a great DCS system. I will say that there are other DCS vendors out there today that are employing MTP standards, and we can work with those as well. So again, from an OEM's perspective, having that flexibility to work with a range of DCSs would be a great benefit to them as well.
Great. We have a couple minutes left, maybe one more question. And if the audience has additional questions, please type them in and we'll get to them offline. Daryl, can you describe how application commissioning and unit tuning parameters are managed without a laptop or software?
Sure. So in the PAC Systems environment, we have the concept of a remote download and storage device, an RDSD, which basically takes the form of a USB stick. And so if you've got an application that you've developed for a PAC Systems controller, you can deploy it to an RDSD device. And then if you have it enabled on the piece of equipment, you can actually connect, authenticate yourself, and then using that stick, download an application, a runtime application onto that device. So you can think of that as your standard piece of control equipment, control algorithm. So if you need to upgrade 100 units in the field and you've got a standard program that goes onto them, you can just walk up to the machine, authenticate yourself, download the device upgrade, and you're up and running. But of course, we oftentimes know that a standard piece of equipment needs to be tuned to operate properly at that end user's environment. And so PAC Systems controllers now have the capability to be able to store critical data, be it reference registers or variables, to removable media. And that then allows you to take the tuning parameters for that particular piece of equipment, have it on an SD card. So in the event that you have a failure of that controller, now you can reapply the standard application with your stick, and then you can integrate the particular tuning parameters right down to that machine with the SD card powered up. It'll take the new application, it'll take the tuning parameters, and you're back up and running just like you were previously. And as I mentioned, that's a nice benefit. If I have 50 machines and I want them tuned all the same way, I can copy that card and download the road I go. Or we have customers that may deploy, 50 different remote destinations, and each one gets tuned specially there. They can keep a copy of that tuning parameter for that
device on an SD card, so that if they have a failure, they can very quickly and easily replace that without tools. So.
Well, thanks everybody for the great questions, and thanks again to our speaker, Daryl Halterman, for sharing his time and expertise. I'd also like to extend a special thanks to our sponsor, Emerson, for today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on the screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Control Engineering and Emerson, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.